Yeah. So basically, it's a formula. So I might call it a MOOC, but basically, it allows you to essentially take something like a website and identify a component of it, like that batch of text there, and then actually redesign it so that you can actually do reinforcement learning. What I mean by that is you're probably all familiar with the idea that you can take a website and A/B test a piece of it, do a randomized experiment where you might make 3 different bits of text and present them. But often you can do an experiment and you can stop it. Maybe you can actually change how often different conditions are presented. But the idea is this is a framework that lets you actually take a component and actually do a really wide range of things, where you might start off experimenting where you assign them fully with equal probabilities, but you might actually then dynamically change the policy. So for example, you would do what you often see in multi-arm bandits, where you change how often you're presenting each version. You might also actually even add brand new actions, so you expand your action space. And of course, you might, if you have the data, start to think about, well, I'm not just optimizing which of these bits of text is best on average. I'm not just optimizing which one makes people stay on my site the longest or learn the most. I'm actually trying to optimize, given the characteristics of a particular user, given their context, given the side information we have about them, which of these impact my reward function the most. And so basically, what this framework does is actually just take a component of a website and allow any machine learning researcher to get data in real time. So every time an action is taken, you immediately see what happened, and then actually to specify policies. So currently, I'm not sure if you've ever tried to run reinforcement learning in a real-world piece of technology, but you might find you do a bunch of programming and you put one policy in place. Then you get data. Then you analyze it offline, and you come back in and try and change it. This actually means that you can actually wide range of policies, algorithms for contextual bandits, anything that you might use for solving MDPs or POMDPs, and you can actually just change these policies just by flicking a switch. There's no actual change in programming. So what that means is you can actually take a piece of website and do reinforcement learning in real time. So that's just some kind of context to the sort of formalism, and in particular because I've actually implemented it in part in a website like Assessments. So given that Assessments is a particularly fertile place for thinking about these kinds of issues and mainly how you could actually start to machine learning in real-world context, I think I'm going to turn you over to Neil now.
Excellent. Thank you, Joseph. I'm going to actually screen share so you don't have to look at my beautiful face. And but yeah, Joseph and I have been working together for a while, trying to actually apply reinforcement learning and in these contexts. So I'm a professor at Worcester Polytechnic Institute, and I put a few things up on the Google Sheets that actually Joseph has provided. In fact, I recorded this version of this conversation earlier this morning in case there was going to be technical difficulties. But anyways, I'm in Worcester Polytechnic Institute outside of Boston, and I sit in the computer science department. I teach actually AI. I do a lot of actually Bayesian networks and clustering and random forests and things like that. One of my students won one of the prizes at the KDD Cup a long time ago, well, 4 or 5 years ago. And but I also do a lot of actually randomized control trials comparing different types of interventions. And so I like to put the two of those together. We all just heard about Mark Zuckerberg actually wanted to drop actually his whole fortune into personalizing learning. Well, how are you going to do that? So part of it is actually about assessing, and Joseph tells me that many people in the workshop there might not have actually seen the talk earlier this week at NIPS, but on actually applying deep learning to the standard way of tracking student knowledge inside actually online environments like this called knowledge tracing. But if you did, part of the piece is actually tracking and assessing. Another part is actually deciding what to do about it. So a little bit about my background. I was a middle school math teacher in the Teach for America program, but my goal now is to actually help actually different researchers actually use these online technologies to do better science. So I'm running a platform, as as actually Joseph was saying, my goal is to be like the Jimmy Wales, who was the guy that created Wikipedia, but for open homework support systems, and to actually do that where we can crowdsource feedback from teachers and kids and learn what is effective, ideally in real time. Right now we do a lot of this offline. At the end of my talk, I'll actually mention data set that actually we've used for multi-world testing. So we're working in there. But let me just give you a little background on actually the assessment system. I give it away for free, and that's the Wikipedia, I guess, style. But we also give all our data away for free, and but it's all been anonymized. And I care a lot about actually doing this sort of stuff in the context of an open science world. So what is assessments? It's a simple online platform. Kids get actually immediate feedback. So do their teachers, their school administrators, and parents. That's flexible content for teachers to use with actually pre-built problem sets. Teachers can edit their own problem sets or actually build their own problem sets. Has a bunch of useful features. And if this were a talk of a bunch of school leaders that I do a lot, I would actually go on and on about actually why this actually is really good for your kids and your schools. And we have a lot of actually good research on actually why that is true. But since this is a talk meant for actually people that care about reinforcement learning, I will actually ignore all that and actually try to actually say maybe just a little bit that's maybe relevant. So at the moment we have about 50,000 kids that actually use assessments. I've actually been able to use a lot of funding from the National Science Foundation, U.S. Department of Education, and others to actually learn how to actually do this. I guess actually I should say to build this infrastructure and to answer interesting research questions around actually optimizing student learning. So the mission of assessments, I guess from many teachers' perspective, is, hey, this is a lovely, valuable service for them. I look at it as actually it's a service for me to actually get research done. So it's a learning science research platform. It's open to researchers now to propose randomized controlled experiments on my subject pool. And so Joseph is part of that NSF grant. And we have actually 13 researchers right now who have actually proposed studies inside this platform. Just yesterday, I was at the U.S. Department of Education fundees meeting, and I met actually for the first time one of the people that has proposed a study. I met her in person, and her study is, I think, right now under review and will soon be published. So in that case, this is a researcher that comes to the assessment platform, goes to the assessment's testbed infrastructure, proposes a study. We actually accepted it, run it, and actually she gets actually data on this. And so right now, Joseph and I actually have a paper actually in submission right now at the Learner Analytics Conference, articulating out what does that look like? What does that infrastructure look like? As well as actually this data set, as well as actually articulating clearly the types of data that actually these researchers get. And so you could use these types of actually things for multi-world testing. We actually, as part of this, I think we have something like 20 experiments. I think actually 8 of them are on different topics but the same experiment. In this case, actually comparing text versus video. And so if you like multi-world testing, you might find that useful. So all of our data is open, as I said. So we've been lucky enough to actually get some nice press from the New York Times or NPR or the Boston Globe. I've been working on assessments for a while. But we do a lot of different types of experiments, and to maybe get a sense of actually one of those that seems particularly more relevant, let me actually demo first a little something about actually how we actually structure our experiments. So This right here is a worksheet, a Google Doc actually, where we're actually keeping track of what looks like, I think, something like 150 different experiments submitted by different people, and each of these people actually gets emails actually from us on a weekly basis, letting them know how many people are in their study. I don't know, this particular study, study number 10, has got actually 1,400 kids that have actually completed it out of actually 1,605 students that started it. So in this, types of experiments, and one experiment in particular that I want to highlight is the type of experiment where we actually look at actually personalization. And so, as I was saying, our goal, of course, is to try to figure out how do we actually best personalize learning. And so I'm going to go to my website. I'm going to go click on our examples link. And from here, you're going to actually find right here 20 different randomized controlled trials comparing different types of feedback, worked examples, types of video, whether we give kids choices or not, a whole bunch of different actually contexts. Some really cognitively based, others actually like, oh, what if we actually put cartoons in between actually problem solving episodes? Can we actually decrease boredom? Quick answer is no, we can't. But one of the more interesting actually studies we actually did is to tutor or not to tutor. And so this study actually was comparing whether you give children a complete worked out solution or whether you give them actually tutor problem solving, which is actually step-by-step feedback where we give them a problem. If they get it wrong, we'll ask them first a question about the first step, and then a question about the second step, and then finally a question about the third step. If kids need help, in this little yellow box here, they're getting feedback. The result of actually this study was that we got what we call a personalization sort of effect. And so by that, I really mean, and if you go read the paper, which I'm downloading as we speak here, you get actually what us actually educational psychologists would call a subject treatment interaction. These little crossing lines are kind of saying, hey, if you walked into the study and you had low knowledge, you're better off with this tutor problem-solving feedback as opposed to if you walked into the study and you had high knowledge, you'd learn a lot more if we actually gave you the complete solution strategy. So when we did this as a pure randomized controlled trial. We were randomizing, we were not using bandits to actually answer that sort of question. But we could, and it's the sort of actually stuff that largely due to my collaboration with Joseph to actually help us actually think about using bandits in these types of situations. I like to think about actually bandits as a useful way of actually thinking about actually more ethical experimentation as we actually learn which conditions are working or not working to actually quickly stop doing that condition and move that child to the condition that we think is most useful. So I also do a lot of non-randomized controlled trials, and in fact, it's really nice to see that actually a bunch of the types of actually studies that actually we've done lately have gotten a lot of actually a lot of attention. Particularly, actually, we've done these data mining studies where we actually track student emotion over time, and then we use that, and we can basically detect. Basically, Professor Ryan Baker at Columbia has done a good job of building machine learned detectors to detect boredom, frustration, engagement, and confusion inside our environment, as well as doing that in 10 other educational environments. So while I love randomized controlled trials, it's not the only thing I do. I will say that actually, after I've just told you, we experiment en masse on actually trying to figure out what works. If you're interested in proposing a study, it does need to actually meet the definition of normal educational practices, and like text versus video, or a worked example versus just more practice. Those are all normal educational practices, and that's what we comply with. So coming back to the grant that I was actually referring to at the beginning of this talk, Joseph and I now actually have an NSF SI2 grant where we're helping these multiple researchers actually propose studies and run them in our world. We do this all in an anonymous manner, and as those results actually get published, and all of them will actually go live on our site, that is, the data will become actually available 1 year after the study has been completed. The paper that I was already referring to that actually releases about 20 different experiments done that you could do multi-world testing on right now are stuff that we've already done. So I'm not actually releasing studies data from other people's studies, because these educational psychologists, they of course want to be the first person to study to actually publish upon their data. I have 2 more slides. Second to last, I want to actually say that actually Assistments, while being a platform, it can also actually be embedded into anything else. And so, as actually Joseph was saying, he's done a lot of work with edX. He's also done experiments actually working with Khan Academy and other places. But because he's paid a lot of attention to edX, he actually was helping me see the value proposition of making sure that Assistments can run inside edX, and so it now does, using something that's called the Learner Tool Interoperability Format, which actually basically means that you can it can now be embedded in all sorts of environments, not just edX. I think it's already apparent that I'm actually some sort of randomized control trial fan or fanatic, we actually, of course, want to actually use things like reinforcement learning to try to actually do that in more intelligent manners. So the 2 papers, so I think I just want to end with, and I already just showed you actually one of the pictures of the 2 papers, but when these 2 papers are released, anyone can actually go pull down those data sets and actually do their own experiments with them. So I think that's all I wanted to say, and so my talk is over. Let's have some questions.
Thanks, Dave. So any questions people have?
So what happens when one of the proposed studies involves a bunch of UI changes or other redesigns? Who actually does that work?
So studies that actually involve UI changes. Because of actually what Joseph has done with us, particularly where we actually allow actually external pages to actually run. So meaning we can actually host objects, or I guess I should say host pointers to objects that actually allow us to experiment. So basically, most of these studies that I was actually mentioning that are run in Assistments are run by actually building their own experiment in our graphical user interface to build what we call a problem set. Those problem sets are essentially a small programming language that includes if-then-else statements, as well as actually random choice elements. Those random choice elements at the moment do not actually allow you to actually have a mooklet, or excuse me, like some reinforcement learning agent decide assignment. At the moment, assignment with these choose conditions is simply a random assignment. But basically, you don't actually have to build. You don't actually have to do the graphical user interface. If that was the question.
I mean, so this is a pretty different workshop talk from the others, and the main kind of key idea I think coming out of this is saying, here's one example where there's an application context. this is a platform with real students, thousands of them. And so I was put it to you or people listening in, how does this kind of, the fact that there's this open science where data is available, logging student activities, you can try and predict things like whether students drop out of college based on their behavior in a math problem. That's one of these studies you mentioned. In what ways might this be relevant to you all as people who focus on machine learning or part in this community? Are there particular data sets you'd be interested in applying algorithms to, just as straight out applications? Does it raise sort of ideas about new computational problems that people might start thinking about? I think especially, there's a ton of work on reinforcement learning, a ton of work on bandits. But what's actually really rare is to actually have these policies dynamically change in real time. So Niels said it's not implemented yet, but it's pretty easy for us to implement, and I have done it in just some of my own studies. The ability for you to basically turn any A/B testing, any randomization, into just full-out reinforcement learning. So the idea would be that the action space is basically, do we give people hint 1 or hint 2 or hint 3, hint 4? Do we add hints at any point in time? The reward functions are things like whether students keep solving a problem, or whether they drop out, or what literacy is. And the state space now is any feature of a user. What they did before, what their class is like, their gender, their demographics. And so I'd be kind of interested if that's opening up ideas about just kind of computational problems you have when you actually implement these algorithms into the technology that people are using every day. Any questions you have? Any thoughts about that? I'm curious, how many people in here do reinforcement learning research? Okay, so, okay, I thought that's like everyone who would come to this workshop. Okay. So how many people here like have implemented a multi-arm band? Okay, all right. So I guess I'm trying to understand the sort of audience, if you don't mind participation. Can I just know, now, what do you work on in machine learning? 23, okay. And you work on helping systems design better ads, but not actually like through experimentation. Got it, okay. And what do you work on?
Active learning.
Active learning, you said to...
In the sense of, intelligent brain.
Okay, so then the kind of computational problem that might be relevant here would be if we're trying to diagnose whether someone understands the concept or not, choosing which problem to test them with. Right. Okay, it's just you sort of kind of get a sampling of what people are thinking about or looking at. But good to know that actually I would have thought, well, thanks for coming, guys. I would have thought only reinforcement learning people would be interested in this kind of issue. Any other questions or comments?
Is this look like mostly aimed at elementary school students, or is there part age range? Or?
It is mostly middle school students.
Yeah, but you can basically just, someone said about UI, I think soon, basically, what I think of this as is basically, the NSF grant was for cyber infrastructure. So basically, NSF says, well, what's the technology infrastructure that underlies proper, high-quality instruction, health websites in the 21st century? So when we sort of take the next stage in assessments, the idea is that you should be able to just take the lesson you're teaching your students and author it so that you can actually do some A/B tests and actually get data about what's working. But you can actually just run reinforcement learning on that. So the idea would be when you're making a lesson with some math problems and you write 3 different explanations for your students, you'll actually be able to either use a toolkit like what John Lampert is going to talk about later today, or get your machine learning friends who's implemented Bandit to actually in real time optimize which lessons are helping your students. So really kind of pushing interactive machine learning where something like assessments would be basically some infrastructure where without any programming need, you just make some versions of something, write out explanations, write dynamics of hints, and then you can actually run algorithms for learning what should go to which person. And also seeing data in the formula that RLB, assessment learning infrastructure, provides. If you haven't worked a lot with web platforms, you might not be aware, but basically I want to assume that data can be gotten until I've seen it in my hand. And I want to assume you can randomize anything. So a big part of this is almost like a user question where the user is a researcher. How do you provide data to researchers, instructors, so that they can actually respond to it in real time? Instead of it gets run with 100,000 people, the data gets scraped, and like 2 months later, you're now looking at the data. Anything you want to end on, Neil?
I think I covered lots of stuff, so thanks very much for hosting me, and actually I'm really sorry I couldn't actually be there in person.
Neil's going to, and the whole thing's on Google Hangouts, so also someone else, Deja, who had these issues, was to make it, she's listening as well. And it's recorded, so if you think people would be interested in this, you can always share. All right, that's not everyone.
Thank you.
So 2:15 will start off with spotlights and posters, but you can have a break till then. Or you can start getting people, jumping on people's posters already if you're already excited.
Always good. Always good. And tasty. I know, but if you're yeah. Sure. Okay. I guess that's more. So from the comprehensive, I looked at it seems like they got the comprehensive scope and then both that's all of the sciences. Yeah. So it's using because I always think that so yeah, for example, these are the one that I say think why it was expected. Human operator. So instead of the information think you can be able to talk more, but basically using the metrics that you about measuring those, usually they can direct metrics, surveys, and try to estimate those, and then you can do some kind of system.
So I'm curious. So what is this field exactly? It's like I'm just gonna Google some stuff because I mean I kind of have to cross a lot of different scientific fields, so that's why I'm always
I know, me too. So
So
understand.
what is this field called? Cognitive engineering? Is it a field?
I think so. I mean,
I only know of this one lab.
Oh,
Yeah,
okay.
but it's a field.
There
Okay.
you go.
Ah, wow.
That's just very complex systems.
That's got it. Okay, and so yeah, so you
It's
guys come pretty high.
from-
Oh, so okay.
Yeah, I mean, from my view, I think there's definitely some what do you call that, overlap with
Yes.
HCI. So
Okay.
if you're doing HCI, then yes, there's definitely a lot of overlap there.
Well, I'm actually kind of new to HCI, like
Okay.
a year or two. So even discovering HCI was a field, I was like, okay,
Yeah.
that's interesting. Okay.
My gut feel, but having worked there for 2 months, is that when I
Yeah.
talked to them about the difference, so I asked them what's the difference between HCI and what you guys are doing,
Yes.
right? So that was my first question.
Yeah.
Oh well, if you look at HCI, because they're really just concerned about task efficiency. So when they compare experiments, it's always just how much faster were you at the task, how many questions do you get correct,
Okay.
things like that. Whereas they're more interested in which cognitive model was more accurate, describing your behavior, right? What kind of what was your workload? As I also mentioned before, what was your workload during the time? What was your confusion? Stress factors, things like that. And then evaluating
Stress factors. Okay.
so they're looking at different metrics. I would say more the human side metrics rather than task metrics. That's how they're looking at it. And I would say that I'm not, since I'm new there, I'm 100% sure what the whole field is like yet. But I'm building through osmosis, building an idea.
And so, I mean, so that's kind of a conceptual way that you might distinguish the field. I find, especially having looked across systems, I find it so, since I actually distinguish fields by who's the community, like who the people and where they publish. So like,
Human factors. So a lot of
Oh, so this is
human
it.
factors journal. So that's where I see a lot of publications.
Got it,
They
okay.
also publish in HCI, but much less so.
Got it. And what are the main conferences?
The main conference.
Yes.
I think it's just
Okay.
human factors. I know that human factors journal.
Sure.
Let me go and ask.
I mean,
when I was looking at composition and it's kind of machine learning.
Got it. No, it's
I would
interesting.
definitely
Yeah,
ask.
I'd be curious just because it helps me build up because these all seem like pretty relevant, you know.
That is precisely the question. I need
So-
to go and ask Greg because I was asking, can they point me to something in terms of some cognitive models
Yeah.
so that I can start building our framework a little bit so that I can understand the language
And-
a little bit better.
And what kind of questions are you interested in? I think you could tell me, but if you don't mind reminding me.
No, so we are just interested in basically adapting the user interface on the cloud.
Oh, really? Oh, so that's really that's really relevant. Okay.
Yeah, so you're using contextual bandits.
Yeah.
We are thinking about using contextual bandits, but we
that
don't
would be
know how to do that because Scott is from POMDP and so am I. So we're using POMDP right now.
Sure.
Alright, so we're starting off with POMDP, but we are not exclusively against contextual bandits.
Oh.
In fact, we think contextual bandits might actually be easier.
That's the thing because the truth POMDP is obviously contextualized as a subset, but the problem is dealing with that complexity.
Right. And the thing about POMDP is that it gives us a common language, I guess, for us to talk to the human factors guys about.
Or because they use a lot of POMDP.
They use models which they can, in their mind, get an idea of how state spaces move.
That's
and things
interesting.
Like that.
Okay.
So, I think, at least talking to Greg, it seems like there's some commonalities there that we can exploit. I'll
that's
show you later
interesting.
some,
Yeah,
picture
that would be great.
About, something from Human Factors Journal.
So
That if you look at it, you can go, I can make this into a POMDP, right?
sure, you can like look at it. Oh, that's interesting because I mean, sometimes actually that's just really important in making mappings.
Right. So it's basically an
Yeah.
agent operating the world. And when we see something like that, I guess from the time, it's MVP or POMDP.
Sure. That's
So
interesting.
that's how we are approaching the problem. At least that's our conceptual framework at this point. It
Okay.
might change. We're leaving that open, but right now it's a POMDP.
That's interesting.
POMDPs have their own problems. Yeah.
With okay. Huh. And so yeah, that would be really cool to hear a bit more about your name was Harold. Harold, so
Yeah. I
Okay.
need to send you the paper as well. I think it's not on the. I sent you the paper earlier, but it's not on the website. That's all. I'll send it to you again.
no worries.
It was the
non-math. I think it's still in review.
Sure, no problem. So, I would be curious what you think about a concept like a formalism that I've developed. And part of it is a bit more of an engineering thing.
Okay.
But the thing is, I'm not an engineer by training, so I think I'm doing this, but I didn't set out to do it.
Okay.
But the basic kind of concept is actually a way of basically taking an A/B testing,
Okay.
and implementing it, I think, in a superpower way.
Oh, wow. Okay.
So the kind of key idea is basically A/B testing. Let's say you have a website and you want to change some of these components. A/B testing would say, okay, take this explanation and just make versions and randomize.
Okay.
What I do actually is I have an underlying formalism for how to do it so that you can actually just basically, anything you can A/B test, you can actually do contextual bandits, reinforcement learning, and on.
Wow.
So I'd be,
That's really
it'd be
impressive.
cool
Okay.
to talk through,
Yeah,
you know.
let's talk about it more.
Yeah.
Because I know that right now we're at the beginning stage. So this
Exactly,
is the stage
yeah.
where we actually want to get to know what
Great,
frameworks
that
are
would be
there
fun
and
to,
try to collaborate as well. I know
Yeah.
that right now we're just spreading our connections because we need users in the outplace will be
Yeah.
operators as well as people who come from computer science
Sure.
side. So these frameworks are extremely useful for us. So
cool,
thank you
that would
very
be
much.
great, yeah. And yeah, I definitely seeing if they're interesting kind of things to
Okay.
collaborate on. Because what are they? I'm trying to visualize though. Like, what are the kind of tasks you guys work on?
Okay, so we're looking at network operators. So
Okay.
basically, people who like if you can imagine transport network operators,
Okay.
or specifically for our case, it's network security operators. Okay.
Sure.
So people who basically are monitoring, you get a lot of packets coming in, and you're looking at all the streams of data, and how do you make sense of it all? So we work with
Got
a
it.
commercial company called Uncharted, which visualize this kind of data, right? And the question is, based on how do you adapt this visualization in order to help the user understand what's going on, and also
Oh,
to
that would be cool.
target their attention. So if there is there was an attack on a particular node, sure, the common sense thing is to highlight that portion.
Sure.
If they are focused on something else which is also relevant at the time, you have to balance the
This is interesting.
trade-offs and things like that.
So tell me, in an engineering school, is it not uncommon for research questions to come from industry?
It happens, I think.
I mean, this is mind blowing to me.
Yeah, no,
Because
it's,
like a cognitive science would just never even occur to, but I think this is actually a good thing.
right. I mean,
Right. Because so this is like an engineering problem. You're trying to engineer a system that didn't exist before.
right. We're trying to engineer something this before, and
Okay,
the
it's
problem-
probably obvious too, but to me that's a bit mind blowing. It's like that's a scientific question,
Yeah,
right?
yeah. And that's the
Okay.
scientific question behind I mean, how do you adapt something like that while taking into consideration how does it affect the human being, how does it affect the system?
Sure. Okay.
These kind of things come up just purely from having this engineering problem.
About how to and it's not just building that system, but having generalized knowledge about how to build
Exactly.
systems like this.
Sorry, yeah,
Oh, that's interesting.
So we have both sides, right? We have the engineering case. How do you apply this knowledge that we probably can get from
Yeah.
this test, but generalizing so that we come up with a theory. And
That's interesting. And computer scientists, do they do things like this?
I don't know from general computer science, but for me, I guess for me, it's more what kind of learning algorithm would operate best in this kind of scenario, as well as how you balance trade-off. So we're working like multi-objective systems at this point.
Yeah, that's
Where you can evaluate the horizontal surface of policies, and there are trade-offs dealing with the real-world system. And
okay.
sometimes what you think is optimal solution is not necessarily optimal. Of course.
Sure.
So,
Cool. Yeah, it would be great to definitely talk about this one. It sounds like a great convergence.
yeah,
Right?
we have a lot of stuff. I
Cool.
guess.
Okay. Yeah, I look forward to. Yeah, and actually, I did my undergrad in Toronto, so I started to just visit.
Yeah.
Yeah.
Come by.